Last year, the total number of vessels launched by China surpassed the combined output of every other nation on the globe. We aren't talking about a narrow margin here. They more than doubled the rest of the world. As we speak, roughly 70% of all new marine vessel orders globally are directed straight to Chinese builders. These aren't just your average cargo boats. Picture a vessel so gigantic that you could lay 3 professional football fields end to end along its deck. Imagine a single craft capable of hauling enough crude oil to satisfy 10% of the daily energy demand of the entire United States, all in one single journey. One colossal machine, one trip. Naturally, global superpowers, especially the US, are paying extremely close attention. This narrative goes far beyond mere steel and water. It is a profound shift in who holds the reins over global energy distribution. The fuel that warms our living rooms, keeps commercial flights in the air, and runs industrial plants doesn't just magically teleport across the map. It moves across the oceans, and those oceans are being transformed right under our noses in ways the general public hasn't realized yet. By the end of this deep dive, your perspective on maritime trade will be forever altered. You will grasp why the nation constructing these colossal vessels is acquiring something vastly more permanent than mere profit. If this look into global systems fascinates you, go ahead and smash that like button right now. Crafting these deep dives takes an immense amount of effort, and your support truly helps more than you realize. And make sure to hit subscribe so you don't miss our next upload, because this rabbit hole goes incredibly deep. Let's rewind to see how a single power managed to dominate the seas. Historically, the shipbuilding industry was locked in a steady 3-way tie. Japan offered generations of mastery, crafting vessels with an attention to detail that bordered on high art. South Korea entered the ring with blistering speed and cutting-edge tech, assembling fleets at a record-breaking pace. China brought unmatched scale, a colossal labor force, infinite supplies of steel, and a relentless drive to expand that refused to yield to anyone. The international community viewed this balance of power as a good thing. With 3 giants battling it out, nobody held a monopoly, which created a sense of global security. It felt completely safe, and for an era, it really was. But the Chinese industry decided not to just play the same game as their rivals. They looked at the traditional manufacturing models, tore them down, and completely reinvented the process from the ground up. They introduced brand new facilities, innovative assembly tactics, advanced tech, and massive financial backing. All of this was redesigned with one specific target: construct vessels faster, with higher quality, and at a lower cost than anyone else alive. By the time 2025 rolled around, Chinese facilities pumped out over 69 million deadweight tons of maritime capacity in just 12 months. That single figure accounts for over 56% of all shipbuilding on the planet. South Korea, which had been practically neck and neck with China a mere 10 years prior, was left watching from a distance. Japan had fallen even further out of the picture. The 3-man marathon quietly transitioned into a solitary sprint. However, the true story lies in the future order books. With nearly 7 out of every 10 new global orders secured by Chinese docks, we aren't just looking at the present economy. We are looking at a finalized blueprint for the future. The massive tankers that will be navigating the seas in 2040 and 2050, the exact ones still hauling cargo, when today's teenagers are raising their own children, are being drafted, purchased, and welded in China at this exact moment. When you completely dominate the manufacturing of today, you dictate how the world operates tomorrow. To truly grasp the gravity of this situation, though, you first have to comprehend what these machines actually are. Calling them mere ships is a massive understatement. The Very Large Crude Carrier, known in the maritime trade simply as a VLCC, stands as one of the most gigantic mobile structures ever engineered by human hands. Measure it out, and it spans nearly 330 meters from bow to stern. That's longer than 3 football fields lined up end to end. The deck spans roughly 60 meters across, wide enough that you could lay a multi-story apartment complex sideways on it, and you'd still have room left over. Deep within its hull, it transports roughly 2 million barrels of crude oil in one go. To put that in perspective, the U.S. consumes roughly 20 million barrels of oil daily. One of these vessels transports about a tenth of that total. One vessel, one journey. The raw steel required to assemble just a single one of these behemoths tips the scales at around 55,000 tons. To visualize that, imagine stacking 7 Eiffel Towers right on top of each other, and every solitary slice, every fused seam, every connection point across all that mass of metal must be practically flawless. Not just acceptable, but flawless. The sea offers zero forgiveness for errors. The chaotic waves of the North Atlantic can twist solid steel. Violent Pacific typhoons have devoured entire fleets. Meanwhile, deep inside the cargo holds, those 2 million barrels of liquid black gold are never stationary. The oil surges. It violently crashes against the inner bulkheads with every single swell, exerting a relentless outward pressure that hammers the frame non-stop for decades. A vessel of this magnitude must withstand that brutal punishment daily for 25 to 30 years. Yet somehow, Chinese builders can transform raw metal sheets into a fully seaworthy giant in under 2 years. Hearing that timeline at first makes it sound like fiction, but when you examine their actual methodology, it becomes entirely logical. The magic begins at the cutting phase, which is essentially the make-or-break moment for the entire project, long before the vessel even starts looking like a boat. Each of those 55,000 tons of metal sheets is fed into gargantuan, computer-guided lasers. Every single incision is mapped out in advance. These automated machines operate with a level of exactness that refuses to tolerate even a quarter inch of deviation. This intense rigor isn't just to show off. A tiny flaw during the slicing phase compounds as it moves down the line. When thousands of colossal components have to merge later on, a quarter-inch discrepancy on a base plate snowballs into a centimeter gap on a larger block, which ultimately translates to a massive structural vulnerability in the completed hull. Thus, the baseline must be perfection from the very first slice. Now, this is the part where the process becomes truly fascinating. Instead of constructing a vessel using traditional methods, laying a keel, and painstakingly building it upwards, layer by layer, which traditionally chewed up 4 to 5 years, Chinese architects completely deconstructed the process. First, they take the massive master blueprint and digitally chop it into over 100 colossal blocks. Each of these segments tips the scales between 300 and 600 tons. Next, they manufacture every single block in total isolation, installing the internal piping, the electrical grids, and the anti-corrosion paint before the block ever comes near the primary hull. Finally, towering cranes hoist these completed chunks into the air and snap them together like the planet's most colossal and pricey puzzle. This is known as modular construction. The underlying philosophy is simple yet devastatingly effective. Rather than completing tasks sequentially, where each phase is bottlenecked by the previous one, you execute dozens of distinct operations simultaneously, only merging them at the final stage. A build that historically required up to 5 years is now wrapped up in under 2, and the craftsmanship doesn't suffer. In fact, it often gets better, because each individual block can be thoroughly vetted and perfected independently before being fused into the main body. But this raises a massive logistical nightmare. How on earth do you take over 100 massive steel cubes, each weighing hundreds of tons, and guarantee they align with one another perfectly, down to the width of a human strand of hair? Because if they fail to match up, the structural integrity of the entire ship is compromised. This is where the massive technological investments made by China become truly mind-boggling. Across their largest shipbuilding facilities, they have embedded millions of microscopic sensors directly into the construction zones. These devices stream real-time data into advanced AI networks that track every single dimension, every placement, and every microscopic shift. If a block drifts even a fraction out of alignment, the computer catches it immediately, not when a site foreman spots it instantly. The deviations this network identifies aren't the width of your finger or a quarter. They are literally the width of a strand of hair. On a massive structure like this, that pinpoint detection is what stops minor glitches from compounding into fatal flaws. A millimeter off on Block 5 turns into a centimeter off by Block 50, and a disastrous structural failure by Block 100. Catching it immediately is the whole game. And then you have to factor in the welding. Every single seam on these giants must endure for roughly 3 decades. Through corrosive salt water, constant mechanical stress, raging typhoons, and the endless shifting of thousands of tons of liquid cargo. A human welder, regardless of their mastery, eventually fatigues. Their speed waivers, their hand pressure alters, over thousands of hours on the job, even the absolute masters of the craft will leave tiny inconsistencies that they simply can't avoid. So, the Chinese yards outsource the most vital fusion work to machines. Automated laser welding rigs operate around the clock, slicing through solid steel plates up to 50 millimeters thick. They maintain the exact same heat, the exact same pace, and the exact same pressure for days on end without a single deviation. The bonds they forge aren't just durable, they are uniformly flawless, across the board, every single time. Combine all these elements, and you are left with a hull robust enough to haul 2 million barrels of crude through the planet's deadliest waters for 30 years without buckling. But the hull is only part of the equation. What actually propels it is just as astounding. Pushing a 300,000-ton behemoth across a vast ocean requires more than just dropping a massive motor inside and hitting the gas. The mechanics at play here exist on a level most folks never even consider. The power plants inside these vessels are specifically engineered to produce staggering amounts of force at incredibly low speeds. They don't rev high, they churn slowly, driving forward with an unstoppable, crushing momentum. If you were to stand beside one of these powerhouses in person, you'd be staring up at a machine the size of a 4-story office building. The individual engine cylinders are so wide that a grown mechanic can physically climb inside them for routine maintenance. We are talking about nearly 100,000 horsepower. But raw speed isn't the objective here. The true prize is torque, a relentless, overwhelming, continuous push that travels down a massive steel drive shaft to turn the propeller at the stern. That propeller tips the scales at over 100 tons and is forged from a solitary block of highly specialized metal designed to battle saltwater corrosion for decades. It's cast as a single, solid piece, intentionally, completely eliminating seams or joints that would inevitably become vulnerabilities down the road. Every single blade is sculpted, using the exact same advanced computer modeling that aerospace engineers use to draft airplane wings. To give you an idea of how critical this is, boosting that propeller's efficiency by a mere 1% slashes fuel costs by up to $5 million annually for a single ship. Across a massive fleet operating for 30 years, that level of exactness transcends basic engineering. It becomes an economic advantage that can literally rewrite entire industries. And there is one more major hurdle you have to understand: vibration. When a Titanic engine is roaring at max capacity and 2 million barrels of liquid cargo are sloshing back and forth with every ocean swell, the whole vessel shakes. Now, standard vibration is something you can deal with. The severe danger emerges when the engine's frequency perfectly aligns with the sloshing rhythm of the cargo. When those two sync up, they trigger a resonant effect, much like how a perfectly pitched singer can shatter a wine glass. Only out on the water, that resonance doesn't break glass. It fractures steel welds. It exhausts metal frameworks. It silently shaves years off the vessel's lifespan. To combat this, the massive engine is never bolted straight to the ship's skeleton. Instead, it rests on a highly complex damping matrix, a set of massive shock absorbers built to dissipate those tremors before they ever bleed into the primary hull. The giant glides smoothly, even in the most violent storms, and maintains that stability for its entire operational life. Now, imagine taking all of that intense engineering and applying it to a radically new class of vessels. Because the newest Chinese tankers aren't just minor upgrades of what came before. They represent a complete reimagining of what a maritime transport is supposed to be. Take the Shin Aden, for example. It's a VLCC weighing in at a massive 300,000 deadweight tons. But what truly sets it apart from anything that came before are the massive structures towering over its deck. We are talking about rigid, 40-meter, tall sails crafted from ultralight carbon fiber, rising straight up from a hull the size of 3 football fields. These aren't just for show. They are highly engineered aerodynamic structures designed to harness wind power and feed it directly into the massive vessel's propulsion system. Out on the open water, they slash fuel usage by nearly 8%. That might sound like a small fraction, but do the math. On a behemoth that guzzles massive quantities of fuel every single day, nearly 10% translates to millions of dollars saved per ship every single year for 3 decades of service. Then you have vessels like the Yuan Rui Young, which tackles efficiency from a totally different angle. This giant utilizes a dual-fuel engine that can seamlessly swap between standard marine diesel and liquefied natural gas, depending on what is most cost-effective and available in whatever part of the globe it happens to be sailing. Measuring 333 meters long and 60 meters wide, this dual system slashes carbon emissions by 20% and almost completely eliminates sulfur emissions, cutting them down by up to 85%. These vessels are hitting the most rigorous environmental benchmarks in the entire global shipping sector. Benchmarks that the vast majority of older ships on the water can't even dream of meeting. On top of that, this new wave of Chinese tankers is engineered for a 30-year lifespan, rather than the industry standard 25. 5 extra years might not sound like a lot in a vacuum, but for a vessel hauling millions of barrels of crude per trip, those 5 years translate into hundreds of millions of dollars in sheer added value. For a major shipping corporation managing a fleet of these giants, it marks the difference between a solid business move and a generational gold mine. When your vessel is more economical, greener, highly advanced, and outlasts anything your rivals can build at the exact same price point, and it's all supported by highly flexible financing from state-backed banks, that eliminates the massive upfront costs. Ordering your fleet from Chinese yards is no longer just a preference. It becomes practically inevitable, and as those massive orders stack up year after year, something vastly more significant than a mere economic edge starts to emerge. This is where the narrative takes a truly fascinating turn. Here is the crucial detail that almost every news report on Chinese manufacturing entirely overlooks. The vessels are undeniably incredible. The engineering is spectacular, but the true leverage isn't found in the welded steel, the carbon fiber sails, or the cutting-edge engines. The true leverage lies in what this massive fleet represents for the entire global energy grid. Roughly 60% of all the oil bought and sold on this planet travels across the ocean. Not through underground pipelines, not on freight trains, and not in trucks. It moves by ship. And the overwhelming majority of those ships were constructed in China. That single reality forged a permanent, unbreakable chain between Chinese manufacturing and the lifeblood of global energy. Every single barrel of crude that journeys from the Middle East to Asia, from the Gulf to Europe, or from West Africa to the United States, is almost certainly riding on a vessel born in a Chinese shipyard. But the influence goes much deeper than just the manufacturing origin. When you construct a vessel of this magnitude, you don't just hand over the keys and walk away. You establish a binding relationship that endures for the entire 30-year lifespan of that machine. The corporation operating that Chinese-built tanker will inevitably need specific replacement parts. They will require ongoing technical assistance from the exact engineers who understand the ship's DNA. They will need routine maintenance, system patches, and digital upgrades. All of that business flows right back to China, over and over, for 3 decades. Chinese state-backed banks essentially supercharged this entire ecosystem by completely rewriting the financial rulebook. Historically, the single most massive hurdle to buying a new ship was the staggering initial price tag. A VLCC runs into the hundreds of millions of dollars. The vast majority of shipping firms simply couldn't afford to cut a check that large. But Chinese financial institutions stepped in, offering customized financing that broke those payments down over time. With unbeatable interest rates and incredibly forgiving terms, commissioning a brand new supertanker became more achievable than ever before. Suddenly, massive maritime companies out of Norway, Greece, the Middle East, and Asia began dropping larger orders at a much faster pace, simply because the math finally worked out perfectly for them. And every single one of those contracts firmly locked those global companies into the Chinese shipbuilding ecosystem for the long haul. Now, take a step back and look at where power has traditionally resided in the energy sector. For over a century, the ultimate leverage belonged to the nations sitting on massive oil reserves, the countries that could simply twist a valve, alter the global supply, and dictate market prices. But crude oil trapped in a pipeline is entirely useless without the massive ships required to distribute it, and those ships cannot exist without the sprawling shipyards required to build them. Therefore, if you command the global transport network, you wield an immense amount of leverage over the world's energy supply, all without having to own a single drop of oil yourself. You don't have to be the one extracting the resource. You just have to be the one who dictates what vessels get built, how many are allowed to exist, and who gets the financing to buy them. China isn't dictating oil production quotas. They aren't drilling deep in the Gulf, but they are single-handedly supplying the massive fleet that transports 60% of all the oil humanity consumes. And the vessels being authorized and welded right at this very moment will still be navigating the seas in 2055. The logistical backbone being established right now will dictate exactly how energy is distributed across the globe for the next 30 years. It will still be fully operational when the next generation is figuring out the post-oil economy. We are no longer just talking about a shipbuilding boom. We are talking about who is quietly holding the steering wheel of the global economy. It's not being done with loud threats or military force. It's being accomplished with raw steel, automated robotics, carbon fiber technology, and bank loans that make it vastly easier to say yes than no. And when you construct enough of these giants, for enough of the globe, over a long enough timeline, the ocean itself begins to transform. It stops looking like a natural, wild barrier separating continents. It starts looking like a highly regulated network, one that somebody constructed, somebody services, and somebody increasingly controls. From the first laser-cut steel plates to the automated welding rigs, from the wind harvesting sails to the advanced dual-fuel systems, China didn't just build the biggest oil tankers on Earth. They built the entire ecosystem that creates them, pays for them, and keeps them moving for decades. In doing so, they have firmly planted themselves at the absolute center of global energy distribution for the foreseeable future. So, here is the massive question I want to leave you with. When the logistical network that transports 60% of the globe's oil is built by one single nation, maintained by one single nation, and financed by one single nation, does that nation suddenly possess a level of global authority over energy that nobody ever voted for, and that nobody can easily dismantle? Drop your thoughts in the comments down below. I genuinely want to hear your take on this. If this deep dive was worth your time, make sure to hit that like button, subscribe to the channel, and turn on all notifications so you never miss a future breakdown. Our next video is going to pull on this exact same thread, but in a completely different direction that you probably won't see coming.